This is going to be 8.3, derivatives of sine and cosine functions. So far we've been doing a lot of trigonometry and we haven't really been talking about calculus, but now we will. So here the derivative of sine of x is equal to cosine of x, and the derivative of cosine of x equals negative sine of x. So one thing to really note about this is that you can really derive this using the long formula, the long way to kind of derive a particular derivative. They're a little bit complicated because it involves a lot of identities. It involves a lot of things about limits, but that's not really necessary. Graphically, you can kind of figure out if you graph the sine curve and try to estimate the derivatives, you'll kind of can see that it's going to be the cosine curve. So if you have any questions on the derivations, just let me know and I'll be happy to derive it for you if you really want to. But what I really want you to do is that we know that the derivatives is just basically the slope of a tangent line at a particular point for each of these graphs. So one thing that really helps me to figure out these sines and the cosine curves is that if you have sine of x, the derivative of that is going to be cosine of x. The derivative of that is going to be negative sine of x. The derivative of that is going to be negative cosine of x, and then it returns. So these are the derivatives, and then it just goes, and then right after you're done with that, then it just goes back up to the sine. Okay, so that's a really easy way to do it. So what I really want to be able to do is do a lot of problems with using calculus and differentiation. So what I want to do is find the derivative. And when you're finding the derivative, use product rule, chain rule, whatever you got to use, okay? So let's start off with the first one. So let's start off with part A, f of t is equal to t cubed sine of t. Okay, so let's find the derivative of this. If you feel like you're comfortable to doing this, try it out. We're gonna go ahead and do some right now. I'm gonna do this right now. So notice that you have two different functions. Two different functions means the product rule. So I'm gonna use the product rule to take the derivative of this. So you're gonna have f of prime of t is equal to the derivative of the first, which is gonna be 3t squared. I'm gonna leave the sine by itself, sine of t, plus now we're going to take the derivative of a sine, and the derivative of sine is going to be equal to cosine of t. And now we're going to leave the t cubed by itself. Okay. All right. So one thing to kind of note, make sure that you do not multiply these two guys. This is together with the cosine. Okay. So what you want to write is 3t squared sine of t plus, let's write the t cubed on the front, cosine of t. Okay, so you can, so this is very similar, kind of like natural log. You know how you have natural log of x times x? This is not equal to ln of x squared. You usually write the x in the front and then you're done with it. Okay, so this is basically what you want to be able to do. The cosine of something, and you can even write it in parentheses if you really need to. It's going to be inside of the cosine or inside of the sine. Okay, all right, let's do another problem. So part B. Let's say f of x is equal to 1 plus sine of x to the power of 4. Okay, so let's say we wanted to take the derivative of this guy. Okay, so the derivative of this guy will be f prime of x. Notice that you have a function inside of another function. So what we're going to do is use a chain rule. So I'm going to move the 4 over to the front. So it's going to be equal to 4. Leave the inside by itself. Subtract this by 1. So it's 3. Okay, so you're going to leave the inside 1 plus sine of x in the inside. Multiply, let me write brackets. The derivative of 1 is just going to be 0. Plus the derivative of sine is going to be equal to cosine of x. Okay, so this is going to give me 1 plus sine of x to the power of 3 times cosine of x. So I can rewrite this as 4 cosine of x times 1 plus sine x to the power of 3. Okay. All right, so now let's do this problem. F of x is equal to sine of 5x. Okay. So notice that in this problem, we have something inside of something else. So what we have to do is be able to use a chain rule. Okay, so f prime. So what is the outside function? Notice that the inside function in this case is going to be this 5x. That's in the inside. So we have to take the derivative of the outside, which is going to be the sine. The derivative of the sine is just cosine. Leave the inside by itself. And then multiply it by the derivative of the inside, which is going to be 5. It's going to be 5 cosine of 5x. Okay. Let's do a couple more. So let's say we want to find f of x is equal to cosine of the square root of 1 plus the natural log of x. Oh, there should be an x. Okay. Okay, so this one's a little bit involved because there's a lot of things going on. Notice that you have something inside of the cosine and something inside of the square root. Okay, so let's start off with the outside function first. So what's the derivative of cosine, which is going to be the outside? The derivative of cosine is just going to be negative sine. So it's going to be negative sine. We're going to leave the inside by itself. It's going to be the square root of 1 plus ln of x. And now we're going to take the derivative of the inside. So let me write it like this. So we're going to take the derivative of whatever the inside is, which is the square root of 1 plus ln of x. So that's what we're going to do, take the derivative of the inside. Okay, so now I'm done with the red part. So the red part's going to stay the same. Sine of the square root of 1 plus ln of x. This guy, we can rewrite it like this. 1 plus ln of x to the power of 1/2. Okay, so now I can use a chain rule. I can move the 1/2 over and subtract by 1. So I'm going to have 1/2. Now we're going to leave the inside by itself, subtract by 1. It's going to give me negative 1/2. So the inside now is going to be 1 plus ln of x. Okay, so that's what we have. And now what we're going to do is we're going to multiply it by the derivative of the inside. Now the inside is going to be 1 plus ln of x. The derivative of 1 is just 0. The derivative of ln of x is just going to be 1 over x. Okay. All right, so let me clean this up. Let me put this 1/2 to the front. So negative 1/2 sine of the square root of 1 plus ln of x. Okay. Now you have this... this part, this is a negative. Let me write this on the bottom. It's going to be 1 plus ln of x to the power of 1/2. And then you have this x also, 1 over x is going to be on the bottom. You can write it like this. Okay. And if you want to further simplify it, it will be negative sine square root of 1 plus ln of x divided by, there's a 2 on the bottom, there's an x on the bottom, and there's an 1 plus ln of x to the power of 1/2. Okay, and that will be my final answer. Okay. All right, now let's do 2 more. So this is going to be f, d, e. So let's just do f of x is equal to e to the power of x plus cosine of x. Okay. So the derivative of this, so f prime is going to be equal to, so now the inside function is going to be this x plus cosine of x. So the derivative of e is just going to be e. So e stays the same. Okay, so the derivative of e is just e. I'm going to leave the inside by itself, x plus cosine of x. And now I'm going to multiply it by the derivative of the inside. The derivative of the inside, the derivative of x is just 1, plus the derivative of cosine is going to be negative sine. Okay, so if you wanted to clean it up, you can just write e to the x plus cosine x, 1 minus sine of x. You can distribute it. It doesn't really matter. Okay. Okay, e, and then let's just do f. Okay, so f, let's say you want to find f of x is equal to, I don't know, cosine of x divided by sine of x. Okay, so there's multiple ways that you can do this. You can bring it to the top and make it to the -1, or you can just use the quotient rule. So if you use the quotient rule, remember the quotient rule is low d high minus high d low over low squared. So f prime of x is going to be equal to low, which is going to be sine of x. D high, the derivative of the high, is going to be a negative sine of x. Minus high, which is cosine of x. D low, the derivative of the low, which is sine of x, is going to be cosine of x. Divided by, low squared. It's the sine x squared. So what I'm going to get is negative sine. Sine and sine gives me squared. The way that we really write squared is you write a square there and write an x there. Then minus cosine squared x divided by sine squared x. So usually whenever you see sine of x squared, you can write it as sine squared of x. Okay? All right, then now what we're going to do, usually this would be the final answer. Okay? Now, if you're taking a little bit more trig, you know that there's other stuff that you can do. You can take out the negative, sine squared x plus cosine squared x divided by sine squared x. And if you know a little bit of trig, you know that sine squared x plus cosine squared x is equal to 1. This is a Pythagorean identity. Okay, how is that possible? Why is it equal to 1? Well, if you remember a unit circle, in the unit circle, the sine was the x, the cosine was the y, and then this is just 1. This is just the equation of a circle. Okay, that's why that's true. So you will just have negative 1 over sine squared of x. Okay, now obviously you don't need to go this far. This would be perfect enough because we're not really going to do a lot of identity stuff. Okay, so that's basically what you want to do with these types of problems. So it's just basic derivatives. You're just taking the derivative and then just doing all of the rules that you've learned in calculus so far.